Okay, today we're looking at solving trig equations. And before we get started doing that, we need to put up our special angles grid and our quadrantal information, because we're going to need that. So we've got sine, cosine, tangent. I've got pi over 6, pi over 3, pi over 4. So what's sine of pi over 6? 1/2, which means cosine has to be square root of 3 over 2, and tangent is 1 over the square root of 3. Sine of pi over 3 has to be square root of 3 over 2, which means cosine has to be 1/2, and tangent has to be square root of 3. Then I've got 1 over radical 2, 1 over radical 2, and 1. The other thing we need is the quadrantals. So my ordered pair here is 1, 0, 0, 1, negative 1, 0, 0, negative 1. So this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and then I have ASTC. We'll need that information when we're solving trig equations. And everything I just put up on the board, you need to be able to produce that as quickly as I did. It's not funny. All right, we've got 6 examples today of solving trig equations. What does it mean to solve an equation in general?
Find the missing bit.
We're solving for a variable. What does that variable do, though? It makes the equation, each side of the equation, equal to each other. So that's what we're doing here today. So I have 5 sine of x plus 2 equals sine of x. The directions will say find all solutions. Keyword is all. We'll need to come back to that once we get close to finishing this problem. So I have 5 sine of x plus 2 equals sine of x. So what needs to be done to solve this equation? Get the signs on the same side. So I'm going to subtract sine over. When I do that, I get 4 sine of x, and I probably need to move that 2 over to make it equal to negative 2. Then what? Divide by 4. So I get sine of x equals negative 1/2. We can do inverse sine, but we don't do inverse sine whenever we're solving for trig equations. Okay? But we do something similar to it. At this point, I ignore the negative, and I go to my special angles grid and find a match for sine and 1/2. Where are the match for sine and 1/2? Pi over 6. Now, anytime I get an answer from the special angles grid, my answers always come in pairs. So when you get an answer from the special angles grid, write it down twice, because you're going to need 2 answers. So that takes care of the 1/2, but I now need to focus in on the negative. What does the negative tell me? Answer should be negative. That's if I was dealing with inverse sine, yes. What'd you say, Lauren? Where it's at on the graph. What quadrants it is in the graph. So if I'm dealing with a negative and I'm dealing with sine, what 2 quadrants am I dealing with? I'm dealing with 3 and 4. Because everything in quadrant 1 is positive, and the S tells me that sine is positive in quadrant 2. So that means my 2 angles should be in quadrant 3 and quadrant 4. So I need to put one of these in quadrant 3 and one of them in quadrant 4. So what's the trick to put something in quadrant 3? Add 1 to the denominator. So that means this is 7. And what's the trick to put an angle in quadrant 4? What'd you say? Multiply the bottom by 2 and subtract 1. So 6 times 2 is 12, minus 1 gives me 11. Now, This says find all solutions. I have found 2 solutions, but I have not represented all of my solutions just yet. Because how would I get to another solution besides these 2 that would work for my problem? What should we do?
Subtract it from either 180 or 5.
That would give me a reference angle, which isn't what I'm looking for, but that you're in the ballpark. If I have one angle, what can I do to get another angle that produces the same result? Add or subtract 360. Okay, so what we're going to do is but I'm dealing with radians, so what are we going to add? We're going to add 2 pi. So we want to go plus 2 pi n. Okay, and that n just represents, if I put a number in there, that tells me the number of revolutions I want to go around. So you just put n in there. When you want to represent all solutions, you're going to go plus 2 pi n. Now, what's another reason why we would choose 2 pi when we're dealing with sine and cosine, or secant and cosecant? If you remember back to the graphs.
Because it takes 2 pi for it to go and repeat itself.
It takes 2 pi for it to repeat itself. The word is the period. Remember, to get the period for sine, cosine, secant, and cosecant, it was 2 pi over b. Okay, what was it for tangent, though?
1.
It was pi, so keep that in mind. So what do you think we're going to add to tangent stuff? We're going to add pi to tangent stuff. All right, so we got the trig function by itself. We used a special angle grid to get our angles. We figured out what quadrants we needed to be in. We wrote those down, and since it wanted all solutions, we put plus 2 pi n on there. Okay, there's the first one.
And you don't have to add it, you just leave it.
Leave it. That represents all my solutions. If I put any whole number in here for n, it's going to give me an answer that works. All right, next problem. 2 equals 4 times cosine squared x plus 1. 2 equals 4 times cosine squared x plus 1. What'd you say? Subtract 1. Divide by 4.
Would you take the square root of cosine?
I would. Take the square root of both sides. So I get cosine on the right. What do I get on the left? Not just 1/2. Plus or minus 1/2. Don't forget about that. Plus or minus 1/2. So now we're ready to get our solutions. How many answers will I have? 4. Why 4, Sky? Right. You're going to have 2 for the plus, and you're going to have 2 for the minus. Okay. So what's my match for cosine and 1/2? Pi over 3. So I'll write that down twice. And I know all of these are going to have plus the 2 pi n. Well, if I've got 4 answers, how many quadrants are there? 4. There's 4 quadrants, so that just means I need 1 for each quadrant. So the first one's quadrant 1, which means we leave it alone. What's the trick to put something in quadrant 2? Subtract 1, so that gives me 2 for quadrant 3. Add 1 for quadrant 4. Multiply by 2 and subtract 1, we get 5 pi over 3. Yes.
The 2 pi n, do you want us just to keep it plus 2 pi n, or do you want us to solve?
No, leave it plus 2 pi n.
Okay.
Yes.
I'm trying to figure out whether you put the 2, 4, 5. I know it's like you add 1 to the number or multiply 2, but how do you know which one?
Well, if it's plus or minus, that means I'm going to get an answer in each quadrant. So for quadrant 2, it's 1 less. For quadrant 3, it's 1 more. For quadrant 4, it's 1 less than double. 1 more. 4 is 1 less than double. Alright, one more with all solutions. It is 9 plus cotangent squared equals 12. 9 plus cotangent squared equals 12. Subtract 9, so I get cotangent squared equals 3. So the cotangent, don't forget, plus or minus the square root of 3. Or, yeah, I didn't do the square root, did I?
So would it be negative pi over 3?
So what's it going to be? It's going to be pi over 6. Bailey, how'd you get pi over 6? Because cotangent's a reciprocal of tangent. So if cotangent equals radical 3, that means that tangent equals 1 over radical 3, and that's where we get pi over 6 from. Now, tangent and cotangent take half of the answers that sine, cosine, secant, and cosecant do. Okay? So normally when you see plus or minus, how many answers would you get? You would get 4. But tangent and cotangent only require half of those. So I only need 2. So we've got pi over 6 and pi over 6. Okay? And we'll talk about why it only needs half. Whenever you have plus or minus for tangent and cotangent, you always want one in quadrant 1 and you want one in quadrant 2. So quadrant 1, I'm going to leave pi over 6 alone. Quadrant 2, what does it need to be? It needs to be 5. And what did we say we needed to add to tangent and cotangent? We needed to add pi.
No in? No in.
Yeah, we need to add pi in. Now, why does tangent and cotangent require half the answer? Because the period is half as long, so I can get to everything quicker. Because if I do pi over 6 plus pi, where do I end up at? If I do pi over 6, which is over in quadrant 1, and I add pi to it, what quadrant do I end up in?
Third.
I end up in the third. So when I add pi, that just takes me back and forth between quadrant 1 and quadrant 3. Back and forth, every time. Okay, 5 pi over 6 puts me in quadrant 2. When I add pi to it, takes me back and forth. So that's why I only need 2. Okay. Now, I will give you an alternative though. If you don't want to have to worry about tangent and cotangent being different, you can treat them just like sine and cosine. Get the same number of answers and do plus 2 pi. Okay? So if you don't want to treat tangent and cotangent differently, then treat it just like the other 4. Okay? Whatever is easiest for you. Alright. Now we're interested in just answers between 0 and 2 pi. So if I want the answers just between 0 and 2 pi, what are we not going to put on our answers?
2 pi.
We're not going to do the plus 2 pi in stuff, because we're only interested in how many answers I get one time around. Alright. So I have sine to the 4th plus 2 sine squared minus 3 equals 0. Factor. What is it I'm dealing with? What is sine to the 4th plus 2 sine squared minus 3? What is that? Trinomial, which factors into 2 binomials. So sine squared, I'm going to have 3 and 1. That tells me signs are different. That one tells me the biggest one is positive. After you factor, that's the point where you usually want to set it equal, both of them equal to 0. So we do sine squared x plus 3 equals 0. We do sine squared x minus 1 equals 0. So on the first one, I get sine squared equals negative 3. And I hope you see that we're running into a problem there. I can't take the square root of a negative number, which means this is not going to produce a solution. And I can ignore it and move on to the other piece. Add the 1 over, I get sine squared equals 1, which means sine is going to equal
Plus or minus 1.
Plus or minus 1. Very good. Now, is 1, do I find a match for 1 in sine on the special angle?
No.
No. So that means I need to go to the
To the graph.
the quadrantals. Okay, I need to know when does sine equal 1 and when does sine equal negative 1. What am I looking at when I go over there? I'm looking at the y value since it's sine. So pi over 2 and 3 pi over 2 would be my solution. Now remember, when you go to the quadrantals, your answers don't. This time it came in pairs. I had a pair, but when I go to the quadrantals, my answers don't necessarily come in pairs. Okay, I'm only guaranteed pairs if I'm going to the special angles grid. 2 more. Yes.
So that was all in blue, that would is fine,
That's it. Those are the only 2 answers on that. All right, next one. 4 cotangent of x equals cotangent times sine squared. 4 cotangent equals cotangent times sine squared.
Would you subtract cotangent? Oh no, it's multiplied, so we divide.
Say it again.
Would you divide cotangent?
Dividing is something naturally that you would think of, but in this case you don't want to do that because when you divide and a trig function cancels out, you lose answers. So you don't want to do that. So what you want to do is you want to get everything on the same side. You can go either direction. Doesn't matter which way you go. I'm going to take it to the right though. So I have 0 equals cotangent times sine squared minus 4 cotangent. I cannot combine the cotangents since that one cotangent has a sine squared attached to it. Bobby? That is correct. Very good. Hopefully you're seeing that factoring something out is something you need to look for often. Okay. And what did I say on the last one? What do we do usually after we factor? Set them equal to 0. So cotangent of x equals 0. Sine squared x minus 4 equals 0. Add 4. And I get sine of x equals plus or minus 2. Talk to me about that. It's not a special angle or a quadrantal, and it's not even possible. Why is it not possible?
Yeah, why?
Because
of the graph.
If you think about the graph of sine, what do you remember about the graph of sine?
Doesn't go on.
It goes up to 1 and goes down to -1. So if you have sine or cosine equaling a number bigger than 1 or smaller than -1, you know it's not going to produce a solution. Because sine and cosine can only equal numbers between 1 and -1. Okay, on this other one, cotangent equals 0. It's not a special angles grid. It is a quadrantal. We just got to figure out which one it is.
Yeah.
To do that, it's helpful to think about what cotangent represents. What is cotangent? Cosine over sine.
Dang.
Right? And in order for this fraction to equal 0, what part of it needs to equal 0? The top does. So that means I'm interested in when cosine equals 0. So I go over to my quadrantals. When does cosine equal 0? So whenever you have tangent or cotangent equal to 0, put it into its quotient identities, and then decide what makes the top equal to 0. That will give you your answer. Figure out what makes the top equal 0. That's your answer. Last one. Alright, 2 times sine of x equals the square root of 2 times cosine of x. 2 times sine of x cosine of x equals square root of 2 times cosine of x. Get them all on one side. I'm going to move everything to the left on this one. So 2 sine of x cosine of x minus square root of 2 cosine of x equals 0. Factor. What do we do after we factor? Set them equal to 0. So add the square root of 2 over and divide. Alright, so when does cosine equal 0? Pi over 2, 3 pi over 2. When does sine equal radical 2 over 2? Pi over 4. Remember, if I get an answer from the special angles grid, there's got to be 2 of them. Then I just need to figure out what quadrants. And I'm interested when sine is what? Positive. I know everything is in quadrant 1 is positive, and since I have an S in quadrant 2, that means sine is positive in quadrant 2. So that means I can want quadrant 1 and quadrant 2. So the first one's good for quadrant 1. What do I do to get quadrant 2? 3 pi over 4. So when I plug any of those 4 answers back into the original, what's going to happen? Excuse me, what's going to happen? Each side should equal each other. That is correct. Each side should equal each other. And that is your introduction to solving trig equations. What were some of the strategies we used to solve trig equations? We used factored something out, or we did a regular factoring. Okay. Yeah, we factored in 2 binomials.
We use the quotient equation.
Sometimes we had to use the quotient identities. Okay. And if I'm solving for sine or cosine, secant or cosecant, and I get an answer from the special angles grid, remember that they always come in pairs. Keep that in mind. Alright, page 331, you're doing 2 to 18 even. 331, 2 to 18.